All right, it's 9 o'clock here in Vancouver, and we're ready for the last class of the UBC Ecosystem Modeling course, FISH 501. The topic for today is how do I model? So basically, we are hoping that you will bring us questions for how does one do that or this. It's also an opportunity for discussions and for asking questions, simple questions, please, about things we've been doing, things that we have a chance of answering. So that's about what we plan to do today. And starting off here, I would also like to acknowledge that we at UBC is at Coast Salish territory, and as such we acknowledge that we are at traditional, ancestral and unceded territories of the Musqueam people, the Tsleil-Waututh people, and the Squamish people. And I also remind you once again that the recordings are available at the Ecopath YouTube channel and at the Facebook page of Ecopath. So if you search for Ecopath, you can find them. And you can also find the course websites with tutorials and so on at the this new Google site that you have the link to here. And it is, by the way, the intention that this material will be up for a long time if you have the link for it here for the course. And also the recordings of this will be at the YouTube channel and at the Ecopath Facebook page, I think, too. But the easiest place to find them would be at the YouTube channel. That's about it for the start here. And where I normally now would turn over and invite a guest lecturer to speak, I'm going to click my gallery instead and not start any presentation. So not talk for 2 hours for a half-hour presentation as I've done before, but instead ask, are there any questions? Are there anyone who would like to open up the how do I model session? We can move straight to it. Or if you have anything else, any comments, anything, this today is really just for discussion, questions. The floor is open. All right. Thank you very much.
Alexis has a question.
It's a short class. I thought we just made it there.
I'm curious, how do I model swimming behavior for zooplankton on small scales that occurs horizontally and vertically? And there's another component to this. Each of the life cycles for the zooplankton have different swimming behaviors.
Different swimming behavior of zooplankton. Now, in this case here, it certainly is not clear to me what's the research question. What are you? Why are you interested in this?
The research question is, how much do kelp zooplankton contribute to active carbon transport via diel vertical migration? And my approach to understanding this is, first, you have to quantify or be able to represent their different swimming speeds, both vertically and horizontally, to account for the nutrient flux. But I don't know how to model the different swimming speeds that occurs with different life cycles.
I'm not sure that EWE is the right tool for it. It may well be much better to explicitly set up a model where you take, it could probably be an individual-based model where you take the individuals and you give them a range of swimming speeds and you let them move. Setting up that IBM model will take weeks. If I was going to explore that question quickly, what I would do would be, I'm sitting here looking at the matrix now of all you. So I have this is what's it called? It's called gallery view, and in the gallery view I have 5 by 5 cells, and they are arranged like this. So I would take a cell suite like this, or it could even be 5 by 5 and keep them separate and explore it. But I could explore it just with an ecospace model that has cells going just this way. And in that one, I would set it up with different migration speeds. So having a stanza that has a functional group that has a lot of stanzas, and then each of the stanzas would have different dispersal rates. The problem with dispersal rates are that they are not directed. So that's an issue. That basically means that we have to cheat the system to address that question. Now I'm trying to find a way to address this instead of using a couple of weeks to set up the other model, to find a way to address it in an hour. Okay, so I would take a spatial model, and I would next say, we're going to cheat this model. We're going to run it on a daily scale. Mm-hmm. So that means that what we enter, PB and QB values, will be daily rates. Instead of being annual rates, we're going to put in daily rates. So just divide everything by 365. Mm-hmm. Then the time step is 2 hours, and I would use migration then. Each of the life stanza you define for each hour, what is their, it can be an envelope. Jeroen has set that up now, but it can also just be a center of gravity and how much they distribute around that center of gravity. So you set it up that they are migrating, and then you will have to define a center of gravity for each stanza for each hour, a 2 hour time step. So you can have everything moving up and down in the column that way. But it is, you can go back to where we talked about migration. It's basically just when you set up is migrating on the Ecospace group page. It would be more, you get much more detailed out of it if you went in and you defined those streaming speeds. But literally that would take you weeks, if not months, to set that up. The other thing here, you can set up literally in an hour if you have a model. You can set it up that way there. We've used this way of modeling transit for modeling bromelia in Costa Rica. A student working on these bromelia, these plants, ecosystems in those plants up a mountainside in Costa Rica where the temperature differs as you go up, that could act, and then how climate change would change that, could actually be modeled by just taking such a one column 2D model, but making it vertical. In the terrestrial realm, it might just as well be in the ocean. It should work, and you should be able to set it up in literally in a few hours. And if you have any issues with this, Alexis, I'm sure there'll be someone on your committee that can advise you, give you some hints about how to do it.
I know there's this guy named Villy on my committee, so
yeah.
I have a follow-up question for that. I don't know if we've discussed EcoNet in this course, but I understand that is I'm forgetting the word, not a module, but like an add-on that includes particle size distribution for studying particle size distribution. Do you think that is something that would be useful in these efforts?
I'm lost here. I have no idea what EcoNet is. Is it a Marta thing?
It's not a Marta thing. No, we brought over, on request of Daniel Pauly, the PSD, the particle size distribution logic to Ecopath, but I don't think anybody's ever used it. So
Daniel Pauly had a postdoc here 1 or 2 years ago, who looked at who actually used this routine, and who wrote a paper about it, comparing something like 15 different models and getting the particle size distributions out. Many years ago, I made the routine for the particle size distribution. It's basically taking the if you think about it for a second here, for each, we have a whole ecosystem represented. The problem is it's really aggregated, and the information we have is we have a pp value for each group. We have a biomass and a pp value. Now, if we invert that pp value, we get something about longevity, and we can, based on this, get a representation for how big animals are. It's a little bit. There are a few assumptions involved in this, but it is actually justifiable. So we can use this to create particle size distributions. And the steps are not, it's reasonable. The problem is that then you have some big biomass groups like benthos, and you have to distribute those. How do you do that? And that's where the magic of fiddling comes in, as you see it, widening those groups. So that was one of the issues we had to deal with in this. But it is actually feasible, and the module is there somewhere in the Ecopath tools for making these biomass, these distributions. They can be much better if we have species information to inform them, but it is feasible. This is also the foundation for the Ecotroph routine that we haven't talked about here. Ecotroph works with trophic levels instead of functional groups, so it creates trophic level spectra, so not size spectra but trophic level spectra. And for that routine, the problem is exactly the same. How do we deal with groups that are really aggregated? It's easy enough when we get up to groups like cod or killer whales to get species distribution based on what we know about growth function. So we're doing assuming for fundamental lines for growth in these, and we have some additional parameters. We have to actually enter a few additional parameters for each group to get these distributions, but it's quite feasible.
Yeah.
So yeah.
Okay.
But they tend to be up values in them, and when you make these distributions, because you have a big group and you spread it out, and then the next group, so you get some. How do you smooth them? How do you widen them? That's the big issues we're dealing with this. Is that all?
No. Can I ask a few?
Yeah.
So I wrote it also in the Slack channel. My questions first. How do I estimate the data for zooplankton, like production to biomass or consumption to biomass, or if you have any reference? I do have measurements of biomass, but I don't know the ratio.
The best source I know is Tom Bray and his work. Thomas Bray from Arvi in Bremerhaven. He has a database. There's reference to it in one of the first presentations with Ecopath parameterization. Talks about invertebrates, and his work includes all kinds of invertebrates, marine invertebrates.
And a similar question about phytoplankton, because if there are any reference for production to biomass. For example, I tried to put in my model production to biomass 80. That means longevity of 4.5 days. But then the EE turns out to be 0.1 and even 0.01 for the different phytoplankton groups I have. Is it reasonable EE parameter 0.1.
Do you have, what information do you start with? Do you have estimates of primary production
I
or
have
of
estimate
biomass?
of biomass, yeah. Of each group, yeah. A lot of data about the biomass.
Because if you're getting EE of 0.1 or 0.01, it almost sounds like conversion errors.
No.
It's not from carbon to dry weight to wet weight.
No. Well, I think one of the problems is the main phytoplankton in the lake is a dinoflagellate. It's relatively large and not a lot of zooplankton is too big for zooplankton to eat and mostly eaten by only one kind of fish. So maybe it's...
EE was 0.1 and 0.01.
Yeah.
Oh, sorry. It's the other way around then. Patricia Woodruff is working on freshwater systems here in BC, and in her models she has edible phytoplankton and inedible phytoplankton. So there are types, especially big ones, that are simply not being eaten by anyone. Is that what we're talking about?
I think so. I'm not sure. I think so, yeah.
Because then the issue is not so much the PB.
No, but even if one of the groups that are being eaten are still goes up to, the 0.1. 0.1.
Even the groups that are being eaten.
Yeah.
And what kind of POB? What is the POB you're using?
Just a minute. Looking at my that's my question actually, because I know the biomass, okay, but I don't know. How do I know the POB?
You're dealing with a warm lake that has pretty cold winters. Is that correct? So it's a strong seasonality in the lake.
Strong seasonality, not very cold, but yeah, it's cold. It's mixed in winter and it's stratified in the summer.
Yeah, and then you have a spring bloom and a summer bloom or something like that kind.
Right. Yeah.
Yeah. Typically for that kind of lakes, we're talking about EEs up around 0.5 being reasonable for the edible phytoplankton.
Yeah.
And this is not anything magic. This is just it's really just a qualified guess, because one of the things that happens when you have blooms is that you have marine snow, and you know some of the phytoplankton will be settling out. If the lake or if the marine system has clear water, like tropical waters tend to be without strong seasonality, you expect that the phytoplankton will be eaten, so therefore high EEs. So that's why I sound so confident when I say 0.5. I really don't have much to have it in, short of that it's what seems to be emerging, and it makes sense. So that's, but 0.5 is, it shouldn't be very high EE, and they are being eaten, so it should not be 0.01 either. 0.1 is also low for such groups.
Yeah, but the issue is that if I, for example, okay, I don't put in...
Your PB is that 50 to 100 range.
Yeah, but for example, for that phytoplankton that does getting eaten, I get P2B like 17, which is way too low.
POB of 17?
Yeah, which is way too low for phytoplankton.
That's very low for phytoplankton, yeah. I mean, on the good conditions, many phytoplankton cells of the edible kind can divide once per day. So the question is, how many days do they have good conditions to do that in? The rest of the year they don't do much. But again, this is one of the things you have to dig in the literature to find out. It's not a modeling question.
Right. So I generally get it. And my last question is the same for the seasonality. I do have some research question addressing seasonality, and I do have a high seasonality in the phytoplankton. So should I use smaller time steps than I don't know, daily, weekly, monthly? Monthly, I think it would be too big.
What are you trying to do?
I'm going to do an ensemble modeling, two lake models and EWE. Lake models that include the hydrodynamic model, and then run some climate scenarios. And I want to see the effect of climate scenario on the zooplankton and fish and phytoplankton communities. So if I'm and it does, and also the seasonality is very important. The other models run like daily. I'm going to do a zero-dimensional.
So in Ecosim, it's very easy to cheat the system. Ecosim internally can work with final time steps. We set that up in connection with work that in the North Sea, combining coupling EWE with Ecosim with Ecosim. Jonathan Beecham said he was working with us on that. He was the one driving it. I think Jeroen and Joe changed Ecosim so it could accept any time step. So we can do that internally, but there's no interface for it, and it's not quite clear what, because of all of the things on. What about time series, different formats there? So the easy way to handle this is to cheat the system, which you again can do if the other models are daily. You could, for instance, if you enter instead of annual pp values, enter monthly pp values, you will have a time step of 30 divided by 12. So you have 2 or 3 days. I've used some kinds of times. I've used 12 my PP and QP values and catches, made them per 12 days, because then 12 days, because then the time step is a day. So that would be one way. Then you have the same time step as in your hydrodynamic model. Is that correct?
So just to understand, so I just put my data instead of, I don't know, defined currently as yearly. I divide it by 365 and
divide by 365, multiply by 12, and then you have a daily time step. Your time series will be daily.
Right. I can define a monthly. You said multiply by 12.
If you want to do it monthly, then it's just divide by 12. Yeah.
Yeah. Okay. But if I wanted, just in order to define it as cheat the system, just put in values that I transfer into daily values.
I should also, maybe I should say for everyone, when we are trying here to find quick ways of doing things, it's again because when you try things, when you do things, you learn a lot from it. There's some say that 80% of the insight comes from 20% of the effort, indicating that the last 80% you don't really learn much from them. But one thing I've come to appreciate is really that questions like this, you can very often find a way around it and do it quick, and you may have to cut a heel like Cinderella, sisters, to get things done, but you can get them done nice and easily. And in that way you can find out, is this even going to make sense? Is this going to work? And if you want to, then you can make a real model that's much more complicated, and that will satisfy reviewers and committee members better, perhaps, unless they are people who understand that you really get most insight just from trying it. So this is also why we're really advocating that don't get all your data lined up before you start modeling. It really is important to get those models going, see what they say, and then find the data that you really need. You don't know it beforehand. Nobody does. So finding a way of just doing that modeling and then informing it with data afterwards and doing it more detailed, that works. And yeah, EWE is really flexible when it comes to finding a way of doing something. So let's see what else we can find.
Thank you.
I was just wondering, we talked about model coupling and ensemble modeling a lot during class, and I found I was a bit confused about the difference between the two, and I was wondering if model coupling is better for certain questions than ensemble modeling, and vice versa.
Yeah, as Marta points out, it really is two different things. The model coupling is, and even the model coupling has two steps in it. We can link the models or we can couple them. And typically we talk about linked models if it's a one-way feedback, and coupling. Coupling can imply that it's a two-way coupling, that there's a feedback. It doesn't have to be so. For that, what we tend to do is because very often if it's with hydrodynamic model, we get into the issue that hydrodynamic model takes forever to run, and our models are fast. So we don't want to wait and do a run with Ecospace every 2 weeks when we get an output from the hydrodynamic model. We would much rather do it so we can get the Ecospace model running, and then as we run it, we get information from the hydrodynamic model, and we may be passing something back there again. The big issue there is who handles zooplankton. If you have a hydrodynamic model with a biogeochemical model, such a model typically has the hydrodynamics, and then it has nutrients, and it has some form for phytoplankton and some forms for zooplankton. Zooplankton in such a model doesn't have any predation on it. So how do you let the zooplankton die? How do you avoid that they continue forever? The way that they're doing that in biogeochemical model is to add a closure term, which is they take the biomass of the group and then they put a mortality term on the group, which is biomass squared or something like that. So the more they are, they also die off, and that way you get a reasonable behavior of them. But if you couple the model, then you can get feedback from the upper trophic level, from the EWE model, for how much predation pressure there is on the phytoplankton or on the zooplankton, wherever you prefer that to be. And that may vary a lot over the decades, how much there is there, what happens to the planktivores. So that's actually a good argument for getting the models to talk together. And talking together is the foundation for this. How much predation pressure is there? Now, one question that comes up in this connection here then is, so who's going to handle zooplankton? And I remember once we did that recently, it was kind of fun because I was telling Jan Bruggerman that we were working with at the time, well, you do that. And he was saying to me, no, you do that. Which is what it ended up with, because we both realized there are issues in this, and I think we are getting to the point where we think that EWE handles it better. So there's no that it is a good way of doing it. That the biogeochemical model looks after the hydrodynamic, the phytoplankton, but the grazing pressure on the phytoplankton comes from the EWE model. But there hasn't been any conclusive studies to actually demonstrate that. So this is just what the expectation is right now. I don't think we have really demonstrated clearly. But Jeroen and Marta, have you seen such demonstrations? What's the best way of treating zooplankton? I think there are indications that that's moving us in the direction of when you are doing this coupling or linking, doesn't really matter. Linking is just we read files that come from it and we pass files back again. I think Ecosim actually handles it better because of the way it deals with upper trophic level grazing pressure, which really is a well-known problem, recognized problem in biogeochemical models. That closure, getting zooplankton killed off in biogeochemical model, is not ideal with a closure term. Having a variable grazing pressure is better, and Ecosim can produce that.
And Villy?
Or Ecospace, yeah.
What is then an ensemble model? Can you explain it as well? What's the difference between coupling and ensemble modeling?
Marta is in a great place to understand that. We was talking about fish meat last week. So, Marta.
Yeah, I was just replying to Alexis. Last week when I explained you how we were running EcoOcean within the fishermen context, where there is several global marine ecosystem models that we run in parallel, and then we compare results. That is an ensemble modeling approach, where we are running several models in parallel, and then we are comparing the results. And what's, for example, also what you're seeing in IPCC reports, those are also ensemble modeling projections, where you see the mean and then you see the confidence intervals that those runs are providing. With EcoOcean, actually, we are doing coupling, one-way coupling or linking, and we are doing ensemble modeling. So both.
And really important for those ensemble modeling is that the models agree on the data to use and the questions to ask of the models, that's comparable. That's the only way you get comparable output out of them. Where you have a chance of understanding why are they different. That's one of the really important questions from ensemble modeling. When you see outliers, why are there outliers? Oh, it's because this model cannot do ice very well, for instance. It doesn't have ice in it at all. It can be that kind of questions that come into play, and trying to understand those differences is a key to ensemble modeling.
Yeah, I just couldn't remember if EcoOcean was publicly accessible that we could explore.
Well, EcoOcean is under development, but we look forward for collaborations and projects to deploy it and to keep on developing it. So it's something that we do collaboratively. So it's several of us. But all the results that we have been developing, for example, under FishMeep, are all available. So you can download them and you can explore them, you can subset them, and you can do analysis on them.
So if, for instance, you would like to look at some specific global questions, then getting the model and trying to run with it, it's just an Ecospace model. You can run it in any, you can't run it with all the layers and so on, but you can look at the model and see what it does. So you can get the Ecospace model part of it. If you want to run it over time, that's why we need to use the machinery that Jeroen and Marta have in Barcelona. But that could be a cooperative project, for instance, for a chapter in a dissertation and that kind of things, where You define what it is that we should be looking at. We make the runs. You get the output, and we work together on the publication. That's the kind of things that is quite feasible. So we are actively seeking cooperation on this.
I have a follow-up.
It's even defined as my discovery grant activity, which means definitely also interested in this.
Follow-up question to that. Can you use the output or system model data at a regional level? Or do you have to do it globally?
That really depends. Again, every model is built for a certain research question, and these global models are built to assess global ecosystem dynamics. But there is also Earth system models available that work on regional scales. So you would not use a global model for a regional case study because of bad representation of coastal cells, maybe not having river runoff, all these other things that you don't get. You're more interested in the global gyres, the distribution of phytoplankton, and all the other things that they do. But there's very good biochemical and hydrodynamic modeling data available for regional models by national agencies, by European agencies. NOAA does great things. There's a lot available.
But I would like to add, though, that in some regions where there's no data at the regional level, where you don't have a regional Earth system model, you could potentially subset the global climate models. And what you could do is, or it has been done before, is to use time series and then use it to run your an Ecosim model and forget a little bit about the spatial dynamics. So that would all come useful if you have limitations on your regional data.
Helena, I think you should talk about, it'd be interesting to hear about the issue for snow crab and fishing only males.
We're modeling the snow crab, which is a newly invasive species. And they entered in 96. We don't really have that much data on the population yet. There's been some surveys since 2004, but they don't really cover the whole Barents Sea always, and they don't capture the snow crab that well. But what that we do have good data on is the males, large males larger than 100 millimeters, which is quite the largest ones. And we don't have any detail on the females or any of the juveniles. So we had to figure out a way to model the total population, because we want to figure out what kind of effects they have on the Barents Sea. Villy has come up with a way of doing it that we're testing out. And that is to, I don't know, maybe Villy would explain. It's been a bit...
Unfair, I talked. But the issue is, what do you do when you have a group where only the males are being fished? The females are released again and are assumed to be, they are released if caught, and they're assumed to survive it. But fishing, of course, will also concentrate on where you find the males. So it's kind of weird. What do you do in a situation like this? So what we're testing now, what Helena is testing, is a new setup that Jeroen and Joe, I think, put together, which is basically, we have two multi-stanza groups, so males and females. And then we have the young stages and the fish stages, and only the male group is fished. Now the reproduction of both groups is then driven by, the big question is, how many females are there to lay the eggs? So that drives how many males will be recruited. So we're overriding the recruitment of one stanza with the recruitment of the other stanza. And that works as long as there are males left. But fortunately enough, in this kind of fishery, it's typically done so that there's a size limit too. so that it's only after reproduction that you fish the males. So this should actually work, that you get, well, it should actually work. And the nice thing about that is very much that it's in line with something I mentioned a little while ago, is that we try to find an easy solution.
Hi. So yeah, the subject has been actually discussed several times, and I don't know, just wondering, what do you think is the best approximation to include or consider seasonality in Ecopath? Because we are explicitly interested in seasonal variations in the ecosystem. So we were thinking on doing, we have data for summer and winter, so do two separate models, static, because we only have data for 1 year, and then do an annual, and then compare indicators among the three of them to see what varies and what doesn't. But yeah, it would be nice to hear any comments or recommendations about it.
I think you know what I'm going to start by asking.
About
what
data?
Is the question?
The research
What is
question.
the question?
Yeah, so we want to know the seasonal differences in the ecosystem, but we haven't defined it further, so different levels of the ecosystem.
Yeah, there's been quite a lot of models that are seasonal, in the sense of Ecopath models, that they describe the ecosystem at a certain point in time, like summer. Especially if you look at the Antarctic or the high latitude systems, they tend to be summer models only, and hardly any winter models because of lack of data. And yeah, you can make a model just of that and derive a number of indicators that describe that. And that's okay for descriptive work. So if that's what the research question is asking for, by all means make two different models that describes the different parts of the year and compare those descriptive models, the indicators coming out of that. It won't let you get very much into what if questions though. That's where you need to get to dynamic models, and working on the dynamics of seasonality. It's kind of funny because Carl Walters started saying it's just like being pregnant. You can't be a little bit pregnant. Either you're pregnant or you're not pregnant. And so either you do seasonality or you don't do seasonality. And Carl Walters is awfully smart, but he's not always right. Meaning, maybe you can have parts of the system being seasonal, not pregnant, seasonal, and not have others. Maybe there are things you can do without going the full way. But you could, for instance, have seasonality. If you have a spatial model, for instance, you can have seasonality in how things move around and overlap. You may have things coming in certain months and leaving again and having a big impact. You can have herring aggregating and have that kind of seasonality, and having the marine mammals, the birds and everything aggregating on top of the herring. That's seasonality without modeling fish seasonality, temperature, all the other aspects. So in that case, you can be a little bit seasonal, not to use the other word. So it is possible. But if you want to do a seasonal model, like when you heard from Vaso Capuzzi 2 weeks ago about the Roberts Bank terminal. Now, in that model, we chose not to be seasonal, even though there's a lot of information and lots of things about what happens over the year. But if we went seasonal in a model like that was going to go through years of review, we would have to have productivity patterns for biofilm and for marsh and for all the other things, how they grow in the course of the year as a function of temperature, because for that model, that's at the level where scrutiny was. And we instead focused on the research question and what is the simplest model that can be used for that. And that was based on average annual condition is assumed to drive the productivity patterns, and we made that decision in order to make the model as simple as possible. So it really is that trade-off between simplicity and complexity. Where do you place yourself there? You really have to go back and you have to address your question, and you have to make sure you don't get into mission drift that, oh, this is really interesting. It's like Santiago when he's hoarding data. He can grasp more and more data. He has to remember what it is he needs to get into those chapters that he's working on, and that goes for. He's just such a nice one to. Anyway, you see that it is really, really, really important to remember it, to avoid mission drift, that you get. This is really neat. I can run with this. Yeah, you might be able to, but do you still answer your question? That part is really important in modeling and all other aspects of our work.
Villy, can I
Yes.
ask you, with climate change that now several EWE models are being used for climate change, and mostly in an annual mode, right? So we run long-term projections about what may happen if average temperature increases by X or primary production declines. Do you think changes in phenology of specific processes, like stational processes, do you think that may have a further impact? And do you think that's interesting to model with seasonality in this context?
I don't know.
Do you know if anybody has developed studies in this direction, looking at how the seasonal patterns in the ocean have been changing? Maybe not.
No, I don't.
I mean,
It's interesting questions. Yeah. Does anyone?
I've seen, like, in papers related to, like, seabird ecology, for example, in the Humboldt Current, that at least fledgling kind of coincides with recruitment for anchovy, for example. And as that has been changing over time, there has been lags and events of lower, I guess, breeding success for the seabirds in years where they're not synchronous. But that's about it. I have not seen stuff related to, like, more complex ecological interactions, at least not anymore. Also, Elena, I sent you a paper on the chat. It's one that was done by Mark Taylor and Coll. I'm going to send it to everyone, and it's a comparison between a model from El Niño and La Niña year, and you could do that for, like, winter and summer.
Thank you, Villy, and thank you,
Yeah,
Santiago.
well, even if you go back to the 1993 Black Book, in that one there are lots of comparisons of two model systems.
Okay, hello. So I have a model for 2016, and I'm fitting it to time series. And then it occurred to me that I'm looking back, and most models I've seen have an Ecopath model of the past in their fitting time series to a closer year. Does that make a huge difference?
Your model is for now, and your time series are past. For
Yes.
reasons, right?
Yes.
We can't run the model backwards.
So how can I go around it?
I have a very pragmatic way of doing it. It's a question that has been addressed a number of times, and I once compared it to saying that there are two approaches. There are my approach and there are Carl's approach. And Carl's approach is because he doesn't want to do all the data work. So what they did in a model, it's a model from Central North Pacific back from the 90s. looking at tuna. They took the present-day model, and then they said this model, instead of being 2000, it's 1930. So they just took that model back to 1930, no fishing, because there was no tuna fishing up till the 60s. Then they ran the model for 30 years, and then they fitted that model from 1960 up to the then present 2000 with time series data. So they had this unfished state, and then they modeled the fish state, and they ended with the current day model. Now the downside of that is, no, that worked in that case, Carl's method. However, it worked because they didn't have fishing. Now, what would you do if you had fishing pressure? Well, you could actually do the same. You would just have to take the first year's fishing pressure and maybe use the same fishing pressure for the previous 30 years, so that it kind of got to a stable state there. Maybe 20 years would be enough, if it's not really slow things. And then you run it forward from there. So you can actually do that. The trend in those is the important part. The Ecopath model is not that important. That is the correct 1950 model, whatever it is. It is how it reacts to fishing changes in fishing pressure, maybe climate issues or other things happening over this time, how it reacts to El Niños and all that kind of things. So that's one way of doing it. The other way of doing it, which is the one I have been using more, has been, we have a 2020 model. We want a 1980 model. Okay, change the year to 1980 in the model and use that model. And then what was different back then? Okay, catches were different, so we put in the other the catches from 1980. Biomasses were different. Well, in some cases we made assessments, so we used those instead. And do whatever we can to get to that. This is if you have data from that earlier period. You would do that. You make your model for today, you describe that, and then you'll make a little add-on separate analysis that says how you changed it into the 1980 model. You change what you can to make that happen. And then with regards to diets, there is the option of saying, I have the present day model. I want to use the same preference functions in that model and in my 1980 model, my present and past model. I want to have the same preference so that a group takes its prey with the same preference as back then. And we have actually a routine somewhere in the tools or plugins or something that does this, so that you can say, you can, from your 1980 past model, you can point to the present model, and you need biomasses of all the groups here. And then it will look at that other model and look at the preferences, selectivity in output, Ecopath output. Look at it and then make the diet composition so that it corresponds to the present model. So the assumption being that an animal today and in present and past takes prey of a given type in the same proportion as it is in the environment in the two situations. So if a prey was much more prevalent in the past, based on the biomasses, you know the biomasses, it would then take it more, it would be more common in the diet as well. That's the assumption that goes into it. So it's two different approaches. They are both really straightforward, and it depends on whether you have some information from your past date, enough information there about biomasses and so on, that you think you can pretty much straightforward develop that. The biomasses are important, PB values are reasonably important, diets are not. You can get them from the present model, and what it illustrates is, yes, there is a way. One has to be pragmatic, and the Ecopath model is not really important. The specifics of the Ecopath model is not really important. What's important is drivers over time. It's the trend that comes out of it that's important. And, we can always do not one model, but you can just throw uncertainty at it, use the routines to have 1,000 different models from the past as starting points in the analysis. The tools are there for that. So don't get stuck with that kind of question. There's always another way, a way around it. And in this case, there are a couple of reasonable, straightforward ways of doing it.
Villy, sorry, Sarah, one question. Why you say it's not possible to model back? I mean, what if we would get the model of the present and then we try to model back reversing the time series?
How would you get from month 12 to month 11 in Ecosim? That's what we don't know. How we invert.
But if you're modeling annually, I mean, if you are you're running your model in annual time steps, could you do that? I mean, ignoring the fact that
we don't know how to make the. It's a question of how to make the calculations from the previous time step. Just inverting those calculations. That's what the VPA does, but doing that in a time dynamic model, Carl doesn't know how to do it.
So if I'm actually doing it, then what does it mean? Because when I put Ecopath in the time series, it does do something.
Our suggestion, I'm only talking about modeling forward in time. I don't know how to run the model backwards. It's complicated.
Yeah, generally, if you're talking about differential equations, you can put instead of initial conditions the end conditions, but you have to rewrite the program to go backward steps. So you cannot use the same software. You have to rewrite it.
Moreover, the whole idea about vulnerabilities is telling you where you are on step 1 in relation to where you can go. So if you are already in step 16, how are you scaling your model using vulnerabilities to fit the time series data? So it's going to be a hassle. I think that it's the Back to the Future approach that Villy is describing is a lot faster and to the point to try to go into the future.
So even at the rational level here, so if at a given point there is a certain number of a prey, what was available in the time step before? Were there many predators that are dying off, or were there fewer predators that are increasing? And how would we know what was there before? Well, we'd have to look at the time series. It's just Marta. I just don't know how to do it. But the other thing, then construct another past model and run that, or construct 1,000 past models and run them, see how you get to the present. I can see the value of making a present day model if that's where the data is. That's what you can get through the reviewers. That's where the information is. So creating a good solid model for the present makes a lot of sense. Make the model for whatever the time, wherever the information is, the Ecopath model, but then use it subsequently with a few additional steps as a past model. I think that's the easy way of doing things, and of getting it through reviewers and committees and so on.
Okay. Do you have any examples of papers that have done something similar and how they justify how to do it?
There is that paper by Walters is on it. Carl Walters, it's North Pacific. It's mid-90s. No, exactly 2000 and something, early 2000s. Jim Kitchell is on it and Sean Cox is on it, but I can't remember if it's Cox who's the first author. It's those three. So it's in the collection of papers.
Mm-hmm. Okay.
So that's one. Oh, must be others. I've helped a number of people doing it.
Yeah, there's several places where people have first modeled the present, and then they have replaced whatever they could find from the past in that model representing the present. So you can, the easiest is to change catches and change maybe some metabolic rates because temperatures were maybe a bit different and things like that.
Yeah.
It's in South Africa, Benguela. We also have done things in the Mediterranean. We can send you some papers.
Yeah, thank you.
Tony Pitcher's group had a lot of Back to the Future modeling, and in there they created a lot of past models. They didn't run them with time series, but at least they created those past models. So they're not the best examples, actually, because they didn't run them. Okay.
I do have a small question. I think that no one else is on the list. I would like to ask you, what do you think is the best approach to kind of predict novel interactions among species? So, I don't know, some predator distributional shift appearing in a novel system. Would this be a good question to tackle with Ecopath, with an Ecopath model of the present, and to add this novel species? And how would we then predict which species could be eaten by this new species? If this makes sense.
This was the topic for when we had Coll here 3-4 weeks ago. We talked about invasive species, or what you call them in the Mediterranean, alien species.
Yeah, whatever. Okay,
alien
yeah.
species,
maybe
invasive species.
I lost this point.
Yeah, so they are. I think that's what you are. That's what you're talking about.
Yeah. So I read something about the different sizes. But this is the question. Yeah, it's exactly this.
There has been several attempts and there's quite a lot of still thinking being put in this. There's a paper by John Pinegar that I can send to you that basically they modeled an invasion of a species that entered the Mediterranean from the east, and they wanted to know what would be eating that species, what would arrive to the western Mediterranean. So they looked at what was eating in the east and looking at what is in the west and made some assumptions and then put it in a full-web model. Also, Jason Ling has been working with it. He has some work done.
Perfect.
And there's many more things to do though in this direction.
If you didn't see those presentations from the day we dealt with invasions, you did okay because there are a lot of papers.
But I will have a look. Yeah, I will re-see them.
Yeah.
And I was also wondering, so do we have any? So do we know how reliable these are? Because now. So I guess it would be interesting to see what we modeled years ago and what happened afterwards in this sense. And I don't know if there are some studies comparing how good of a predictive power these models had or something like that. I don't know.
You mean in terms of trophic interactions?
Yeah, for example, yeah, exactly.
Because for all the fitting procedures about comparing what these models gave us, no? Like what we observe in the past compared to what the models are giving us. But for that we use catches and we use observations like biomasses. The problem I think here is mainly a question that there's not a lot of places where there's time series of trophic interaction. So data on who it's who, yearly or. There's not so many places like the North Sea, no? Maybe, Villy? It's one of the places.
Would be a good case for this. I think this is a really interesting area that needs more attention. not just with regards to diets, but in general how well the models are at making predictions. And the general approach for it is that when you are doing time series fitting, you reserve a part of the data and you use that for making projections. That's, for instance, what we're doing now in the paper to evaluate the different approaches for time series fitting, how well they behave. So we are going to take 1/3 or 1/4 of the data, last part of the time series, and set that aside and not use that for the fitting. So that's one aspect of it, and we should certainly see much more of that kind. It should be more of a standard approach. When we started time series fitting, say 20 years ago, we had 20 years less data in many cases than we do now, and we have much more experience. So now it's much more feasible than it was 20 years ago. Now, an additional thing in EWE with this is that internally in the code, we have the option of using diet compositions in the time series fitting. So all the code is there for it. The only thing that's lacking is the interface, because that would call for interface. It would either call, if it was going to be visible in EWEs, it would need all the interfaces where you'd be able to enter different diet compositions, and that's tedious, and making new interfaces is, well, more work for Jeroen. He's the master of that.
If I understood.
So what, just to round off, so therefore what one can do is to read in CSV files with time series.
Okay.
It's just not, we've done it. Steve Martell developed this in the early 2000s, and I don't think it has been used since then. But the code is there, it can read CSV files, use them as part of this, which basically means that you could, with this, if you want to look at how well it evaluates diet changes, the code is internally there for it. It's a question of just getting it set up. And we haven't done that because there hasn't been anyone asking for it.
And says you also have to know that so you can extract the trophic interaction. So what species are eating in any time. So you could extract that, and then if you have data where you have been sampling periodically, you could compare what the model is predicting to what your real observations are. So that data is there. And I've seen a couple of cases where people have compared that, especially with invasive species, to see what it was predicted that species would eat in the system. When it arrives to the system, it's really eating that. So that is being done, yeah.
That's interesting. Okay, thank you.
But if I understand your question as well, Seska, I thought you also asked that models that made predictions in the past, have they been revisited to see how accurate those predictions turned out to be?
Yeah, it was just an idea. Yeah.
Now, this is something that Colette Wapnitz also wanted to propose for the Ecopath 35 conference as a community exercise to see, okay, the models that were built back in the day and have been producing forecasts up to recent times, how accurate did those turn out to be? That might be an interesting exercise. What do you think of that, Villy?
Yeah, but Villy, I think, so you had way less data than now, and then, of course, the models were worse, no? This is what Villy was... So it's interesting because every day your models get better, and then it's hard to see, no? It's hard to compare from now, I guess. But yeah, sorry, Villy.
No, that's fine. And I'm for the Roberts Bank terminal. This is a $1 million question actually. Roberts Bank has had, I think I mentioned, 35,000 hours of work done there by out in the field. Biologists taking samples and so on. And that's not going to stop, even if they get permission to build the terminal. So there's going to be a follow-up program, and the model predictions are going to be revisited, because the model predictions, among other things, are used to evaluate how much. Spencer, what's the word for it? How much compensation?
Offsetting.
Offsetting is going to be done exactly, yeah. And offsetting is $1 million questions. Absolutely, it's very expensive. So that may be, for instance, that the port is asked, you have to build new marshland, or you have to build new this thing to compensate for what's happening. The model is used to define what the impact is going to be. Those model predictions are going to be followed in the coming years, and if the model predictions aren't good, it's going to cost it may end up costing quite a lot of money to new aspects of offsetting. So that's one case where it actually is really serious. That's the standard, says that we have to live up to that standard of checking the model predictions, and At the same time, you remember maybe from earlier discussion, this very first presentation about modeling, that we can't direct an ecosystem and going to be more of this and less of this and so on, because it is a fluctuating system. And what we have to aspire to when we make these evaluate different scenarios is which of these two choices is the better choice. Very often that's the kind of things that we realistically can use the models for. It's better to increase or decrease this, or it's at that level that we may presently comfortably, I don't know if that's the right word for it, but when we make predictions, it's what we should aspire to is to choose between options, rather than to say I want 6.9 ton of seagrass per, and so on.
So I came up with another question just to try and understand how the model works. For example, let's say one species of a fish is diet, which is a herbivore. It's let's say 80% of one specific kind of phytoplankton and 20% other kinds. And for some reason, this 80% phytoplankton is gone. We have some. How does the model and the actual probably the fish will change his diet because he doesn't have any more of this specific kind of phytoplankton, but other kinds of phytoplanktons available and are actually taking the specific kind of phytoplankton that is gone. So how does the model taking care of it, that this fish will eat more from the other fishes?
Diets in a dynamic model will change over time, but they will only include things that were eaten in the original model. So there's no new prey that's going to come into a diet. So for that reason, if we're talking about invasive of alien species, we need to have them in the original model. Could be with a tiny, tiny biomass and a diet, because the program needs to know how to initialize such a group. So we can't have new diets things showing up. The amount in the diets will then depend on what happens to the consumer, the prey, with regards to biomass and PB and with the QB values. So it's dynamic based on that and the original preference functions. Where the uncertainty comes in can be, for instance, there's been a lot of modeling of menhaden and striped bass interactions on the US East Coast. And one of the real big questions there is, in those systems, you also have, for instance, in Chesapeake Bay, you have bay anchovy, which are much smaller, have lower oil content, and also are quite abundant. The model will change the diet of striped bass from menhaden to the bay anchovy, and yeah, I will do that. But whether that's is reasonable, whether the bay anchovy can support striped bass with the lower fat content and all of that, at least when I was looking at this some years ago, wasn't clear at all. So there are these additional questions come in. Can they actually substitute? So your different kinds of phytoplankton, are they all as edible or not? The model will not know that. It needs additional information to get to that point. And I mentioned here oil content. One of the things that we are very seriously working on now, very seriously, is because it's a promise that we would incorporate this this summer, is to add in the input for Ecopath nutrient content of some kind, one additional parameter that expresses nutrients of something, some kind of nutrient, which could be, for instance, that we do all the calculations in energy instead of in just in biomass. I think it's going to be straightforward, and it will just add a parallel form for account, or an alternative form for accountant if one puts that parameter on top. I think it's going to be that simple. But it is, of course, it requires more data and so on, and that is, Shreya, important for understanding the question you have there.
Yeah, thank you very much. It's answered my question.
I have suggestions here for group photo, and the terrible thing about the group photo is that we all have to go outside, and you know, when you do this, you go outside and there are people not showing up for it, and you have to stand out there, 20, 40 people waiting for the last two to show up. So Jeroen, how would you do this?
I haven't thought about that.
I think that you just need to smile, Villy.
Okay, everybody turn your cameras on for a second.
Just for one photo.
Otherwise, you're going to be photoshopped. I don't know if you want that.
More.
Oh,
more. We have many pictures.
I got a nice one.
Okay, good. Any more questions?
Yeah, I was just wondering if you had recommendations for how to account for migratory species. I know it all depends on the question, but for the model that I'm doing, I'm trying to model mercury in the book, specifically in beluga whales, and they're not in the ecosystem for break down the bearings. But it's important to know, like, we don't really know what they're eating. How would you account for the fact that they're not in the ecosystem, like in my model?
It's a bit like my favorite example of this. That's the Azores model, where the research question for looking at these archipelago is how, if it can call that an island group, do they have to be at the coast to be an archipelago? I don't think so. I think it is an archipelago. Azores. You have to look at the research question. If that is modeling the fisheries of the Azores, then the tuna, for that matter, the whales that comes in there seasonally, you're not interested in modeling the dynamics of those groups, so you can get by perfectly well by just having them come in and leave again. If your question is related, in your case, to the marine mammals, then you have to model them throughout their entire range and on all year. It's a method. The way that you might do this is that if you have I'm presuming you have a spatial. Is it spatial or not spatial?
It's not. There's only Ecopath and Ecosim at the moment, and then EcoTracer, but we don't have EcoSpace.
That does make it a bit difficult to do it with the version that's there. If we're thinking about how it could be made, how it could be done, you would need to use import. You need to have that the food that they eat when they're outside the system, that's import. So that's how it comes into their diet. Then when you're using import in a group, that is something that this group will always get. So if you have that they have 50% import, no matter what happens to the group, no matter what happens to the feeding conditions, the primary production in the system will not matter. They will always get that. That's the only way we can do it, because it's happening outside the system. So we have to do it that way. That's why the SOAs come in. If you want the dynamics of this, you have to model it outside. So let's assume it's import. Now, we don't have any way of saying that in Ecosim that in these 3 months they are eating not the import but the other things. So in a plugin, one could tweak it to go in and say in the winter months diets will be import, and in the summer months that's when they're going to read the rest of it, which is the same as saying you only give them a diet. You included diets. In that case, if we had a plugin, you would include a diet only for the months where they are in the system, and when you are outside of that, you handle the group by basically just don't do any calculations on them. That can all be done in such a plugin.
Another way of doing this would be to force the biomass in Ecosim. Simply force the biomass to next to 0 from the months that they're gone, and the months at the present you force them higher. Let them eat in the system, but it's not a group you can say anything about their lifespan. You just force their presence and therefore their impact onto the system.
You'd have to do that with a time series for a month, on a monthly basis.
Monthly time series, and you can do that now.
Yeah, and then but then the problem is how do you know beforehand what that value should be when you define? If you don't know what time series would be in March or in September of 86, because you don't know the output of the model. Isn't that catch-22 there? Or do you have to do it sequentially? If on the other hand it's a spatial model, one thing we've been doing there is to say that in the months where they are outside the system, we put them up in a corner, and in that corner we just feed them with there's always enough. We just force the food in those cells. In principle that should work, but I don't think we have any good example actually demonstrating it. So it's again one of those cases that we need someone to do it and bug us with issues and how do we get that working. It should be feasible to do this. It really is a question of someone pushing it in the sense of going in and working with it. That's not well expressed, but what I mean is the whole approach is on the continuous development. More and more has been added now for many years, and that will continue. It's really is fundamental for any approach, any modeling approach. If they have to be alive, they have to add new things to them. Otherwise, I mean, who would use an R program that hasn't been updated for 10 years? You know that if that happens, you should go somewhere else. Any kind of software, it has to be continuous development, or yeah. So the group that works with this is really interested in this. There are so many activities. You've seen some of the people here, and new people are joining that continuously. So this is a plea and for a call for cooperation, not a plea, call for cooperation and for development. Okay, we've been through quite a number of things, and we have about 20 minutes left. Before we close, one of the things that we can still continue with our questions. I'm not cutting off questions, but I would also like to hear comments from you about what has worked in this course. How should we do it next year? What you may have of comments there very informally would be appreciated, because we will listen, and we will try to incorporate it into coming classes. I expect, my thinking right now is that when we come to next year, we are likely to be having the course, that we can have the course at UBC in traditional way, but also that we have learned a lot from this course, and all of us from going through what we are all going through right now. I'm getting vaccination tomorrow. Fantastic. But we've all learned a lot from that. So my thinking right now is that next year to do a hybrid, which would mean once a year, once a week, it's going to be online, which based participants can follow from home, and that's going to be the lectures, guest lectures, some too. And then the other one is going to be a tutorial, which is going to be at UBC. Where the registered student will come and probably combine that with having an additional session from those outside UBC to come in and ask questions about it, still do whatever tutorials and so on. So that's my thinking right now, to have a separate session for that and continue with this. Something that is built on for this year. But I'd really appreciate comments about this, and questions are still also most welcome.
If we don't have time series, is it a good practice to assume default vulnerability values in Ecosim, and also assume that the food web properties remain the same, and then use the effort and mortalities panel to change mortalities, for instance, and see what happens to let's say biomass of groups over time?
The short answer, Laban, would be no, because you probably know more. And you're talking about effort. We indicate that it's a fish system where there are changes over time. You may not have time series, or do you? What I would suggest there is, for instance, when you go to the time series fitting, when you go to the vulnerability screen in Ecosim, up on the top there is something about estimate vulnerabilities, a button called estimate vulnerabilities. That's a routine that's hidden in there behind, where you can calculate vulnerabilities based on an estimate for what was the unfished biomass for a group, how far is a group from carrying capacity in essence. So if you're talking about a system where certain groups have been reduced, but you don't know how much, you could see, well, what if there had been 4 times as many groups? I think there were more of this group going back in time. If it was 4 times more, you put in 4, what would the vulnerability be with all the settings for that are there? It calculates that. you can try what if it was 10 times more, or if it was only double more, what kind of vulnerability should be. So you can get an idea about it, and you may be able to argue that. Maybe you may be able to talk to local people that has an idea about. We used to, when we set a net, we used to catch that many kilogram of fish, and now we only catch that many. So some indication of it. Those indications are better than going with default vulnerabilities. So I would encourage you to look for additional data, interviews, historic sources, some way of getting a handle on this.
Yes, it is feasible. Thank you.
The default vulnerabilities in Ecosim, if you just use them without any considerations, and you're using them for something where you have, say, fishing pressure changing over time, this ought to give a very strong, raise strong questions in the review process. It really should do that. It should be questioned by the reviewer why, if that's the best way of doing it. Okay.
Time for feedback or more questions.
I have some feedback. I think this was probably the most organized graduate course I've ever taken. I was, I think, really thankful that you put up all the slides, tutorials, readings up well before the class. Like, that's not common just for graduate classes. And between like Zoom and YouTube, is a new one. I've never seen that before, and it's really, I'm really thankful that we can go back and look at lectures. Slack, access to like 3 or 4 different experts like Marta, Santiago, Jeroen, and all the different guest lectures. Like even going back to Beth in the first class, how she emailed me afterwards and gave me more information. Like the organization of the course, it made it easy for me as a student. So I'm really appreciative of that.
I was very hesitant to start this. We did get a start of it a year ago, but that course was, we went from on-site to online. And I think the hesitancy came from previously when we tried to, or we had this, in the meeting before when you had that some people were there and some people were online, there was always problems with it. It was a distraction. When you had someone in a meeting calling in, it meant everything took twice as long, and those people were being ignored. So that the hybrid was very different, and I think my impression is that this has functioned reasonably well. If I look back at these 25 sessions we've had, I think my regret is that it was only the very first session we had breakout rooms, that we haven't had more opportunity to chat. We've been pushing all this material at you. We can't just double up the number of hours. That would be overwhelming. So
yeah, having more tutorials would have been, I think, very useful. And, I regret not to have done that. But yeah, it's also, we have limited time and.
Yeah, but with the YouTube repository, I think that we can make an effort to run some tutorials and upload them and show people how we fail as well. So that I think would be a good exercise. But I have a question regarding office hours. Like Villy and I have been there for a lot of those sessions, just looking at each other's faces. So why? I don't know, was it an issue about time? Were you already overloaded with courses? Why was that resource not more used?
That's a tricky question here.
You can turn your camera off while you answer, that's fine.
I can speak to that a little bit, Santiago. I went to office hours when I had any confusion or questions. but everything was laid out perfectly well that I rarely felt like I was confused or had to come to office hours to ask you guys something. So yeah, I guess my response to that is, and follow up with what Spencer said, there were so many materials and everything was very organized and straightforward that in itself was enough. But then again, when I did go to office hours, it was really, really useful to talk to you both one-on-one outside of class. So I still think that office hours should be continued.
The lesson we should draw from this is that use kind of changing hours every week.
Yeah, I think maybe even less office hour works too, because like yesterday, I have a question about dispersal rate for the assignment, and I was thinking to attend to the office hour. Then I go to the papers and all the materials that I have as a resource, and I find my answer. So maybe less office hours works too.
I think one more thing that I would add was there definitely was some Zoom fatigue over this term, and I think maybe next year there are fewer, hopefully if the pandemic isn't that bad, and there's less Zoom for everyone, then having these office hours to attend on Zoom won't be quite as, like, I don't know, even some sessions I felt like I could attend, but I was just tired of being on Zoom, so I didn't.
That's a really good argument, yeah.
I would like to add to that in the sense that I have been very tired of Zoom, but at the same time it kept me sane during these months to have these sessions where I can see people from all over the world and discuss science and not just be alone at home. So that's also, I think it also contributed to our sanity to a way. So yeah. Thank you.
One of the things we wanted with the guest lecturers was actually to give you a better idea about what the approach could be used for, and not just focus on methods. So there is the question in this about how the balance between methods and applications and uses. What do you think of that? Marta said more tutorials, which is more methods.
I mean, I've been part of this course for many, many iterations, and by far this is the one.
He's a slow learner.
I am the worst, and like honestly, this thing has evolved a lot, and this iteration I found it the most instructing, because originally when you just learn about this or you read it from the papers, it's very different to see how far you can take it. And like, for example, Marta's lecture or even Beth Fulton's lecture and Jacob Bentley's lecture, all of them were like really out there, like in the extremes, right? And like how far you can take things and how good things can be. So like for me, this has been incredibly enlightening, and I would hope that we can manage to get this kind of like Thursday lecture thing happening and like not just for the course, but also on like the YouTube channel, where we can stay updated and keep track. So we don't need to have a 5-year Ecopath I don't know, symposium. We can have like weekly Ecopath lectures or something like that.
Oh yeah, if you don't know this, the guest lecturers here were almost all of them keynote lectures from the Ecopath 35 conference that was held in just before all of this broke loose in December 2019 in St. Pete, Florida. We've had a 25-year anniversary and 30-year anniversary and a 35-year anniversary of the first Ecopath paper by Polovina, and I certainly expect that there will be a 40th anniversary in 3 years' time, actually, somewhere. There's going to be regular sessions with Ecopath lectures. Leigh is key organizer of that. That will start again probably before summer, one before summer, and then 1 or 2 months between each of these lectures. So that's also worth keeping in mind if you're interested.
One thing we've also been talking about is to organize short videos, how you do certain things in the Ecopath software. Just focus on a specific problem. It's more work to put it together, but it might be instructive. Like, what do you think about something like that?
Personally, I'm a person that learns by seeing for the most part. So that would be quite useful. I agree that for me, it would be good to have more tutorials, but I agree that the time is quite limited to cover everything. And doing a tutorial online is also not the same as when you're actually in a room with your colleagues and everybody can interact during the tutorial. So it makes it a bit different in any case.
Well, one thing we've also been discussing in the past is to organize boot camps. And I don't know for sure if you could do a boot camp online. It's also we've been talking about is to make it a paid course where people would come with their models, their questions, and solve those questions as a group, collaboratively modeling. That is very instructive. We do that through 2 projects now where we model in parallel between different groups across and different places of the world. And to see others struggle with issues that you're also sort of dealing with, it's super informative.
Yeah, we did this at the Ecopath 35. Where we, and actually at all of the 3 conferences, we've had a number of training courses after or before and after the conferences. So we've used those actually to help finance the whole conference, and in some cases also to invite people from less fortunate countries, well-funded countries in, and for the last one we had 2 3-hour bootcamp sessions. The bootcamp sessions were a little bit like today in the sense that people were bringing models, and then we talked about how do you model this part, and we would show the model up on the screen and talk about how to go about it. And I think those 2 3-hour sessions were went really well. Yeah. So yeah, maybe Jeroen, we could do that online. That certainly is a possibility. We learned much more now about what we can do online and how things work.
I would also like to extend my thanks to you for particularly allowing participants who are not registered at UBC. It has been a good experience and we have learned a lot from the course. I thank you very much for that.
You're most welcome. All right.
Villy, are you going to miss us?
Am I going to miss you? Oh. Now, I'm smiling also because when I say I'm going to miss you, the English language is so simplified you can't even tell if I'm talking about you or everyone, right? I think it's been a great session. I must admit I was really nervous about this when we started, and I was really nervous because it's not straightforward having, in this case, 15 registered students and another. We've often been between 40 and 50 on these classes, and really, how do you make sure that the official students are getting enough attention? You saw how nervous I was in the first many emails that you got about this. I think it has. My impression is that it has worked. That it has worked well. So yeah, no, I'm happy with this. I must say I look very much forward to it being spring and to think about other time, because this is actually, surprisingly enough, this has been more time consuming for me than the normal course. Even though I didn't have to give all those guest lectures, it still was way more work than other years. But that's okay. I think it's been fun, and I've enjoyed. I have enjoyed the guest lectures too. even though I've heard many of them at the Ecopath conference and other occasions, it's not the same presentation. Next time, just hearing the new version, most of these were clearly updated versions, and many of these things are so that you don't get it first time. You get much more out of the second time, so it actually helps a bit. No, I really enjoyed it. So yes, I'm going to miss that part, Santiago. I won't promise you I'm going to go through all the YouTube though. It is 11 o'clock here in Vancouver, which means that it's time to sign off, and thank you all.
Okay, thank you very, very much. It was really great. For me, it was just the course I needed. I regret I didn't register to it.
Nice. Take care.
Take care. Bye-bye.
Bye-bye.
Bye, guys.
We close it.
Bye.
We stop recording. Stop going live.